Okay, so for this video, I want to do two variable examples. So, again, some of the things I didn't fully explain, I will definitely cover those, okay? So, like, don't worry. I will explain more as we go. So I want to give a two variable example. So go ahead and do gedit, example, program 2, call it whatever you want, doesn't really matter. What in God's name is this theme? Jesus Christ. Okay. No, 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 no. Feel like I'm looking at a nuclear bomb. Nope. Yeah, that's good enough. What? Okay. So just include stdio.h. Hold up, hold up, hold up, hold up, hold up, hold up. Alright, let me stop. Okay. So int main, and I'm gonna do two variables this time. Actually, I'm gonna make it void. I'll do return in the next video. So we're still doing void. No return value on these functions. So I'm gonna say int a is equal to 5. And I'm gonna say int b is equal to 3. You know what? I'll do some other number that will give some weird hex number just for fun. And I won't print f anything. We'll just leave it like this because I think we get the whole printf thing. Actually, you know what? No, 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 no. Let's do it anyways. Printf, because I'm including the stdio. Might as well use it. So d end line a plus b. I'll spice it up a little bit. It's not really spicing it up, but it's fine. Seriously, it doesn't even indent it? Okay, whatever. New tab, GCC example program 2.c. Ooh, whoops. Expected a matching int argument. Okay. I just realized. Whoops. Okay. So this is just like, it's kind of stupid because this is kind of just a addition done in here. So I will make it more complex later. Like I'll make a separate function for addition and stuff. Um, to see function calls, how they work, cool stuff like that. Wait a minute, what was that error I got earlier? I guess I don't even need this. Why did I do that? Let me see. Yeah. Okay. And then let me just run this. Wow. Okay. What am I doing? Lord Christ. Alright. There you go. 22. So this is two variables. Okay. Alright, alright. So I want to be a little more hands-on in this one. So I'm just gonna go ahead and disassemble main. By the way, before I did this, I ran the command set disassembly flavor intel. Sorry, Intel. Oh my goodness. Okay, Intel. I put that into the GDB that's analyzing example program 2, or the compiled version of it. So I put that before, just so you need to know. And then I disassemble main. So simple prologue. Just push the old value of RBP, move RSP into RBP. Now RBP is pointing at the top of the stack frame. So we're accessing the second empty space in our stack frame, right? In our stack, if you don't remember from the last video, how the spacing works, Google it or do better YouTube research because I suck at explaining that without a full-on video on it. So this accesses the second empty space in our stack and moves in the value 4. This accesses the first empty space on our stack and moves the value 18 because 0x12 in decimal is 18. Alright, and if you're wondering why it put 18 into the first empty space despite us initializing 4 first, initializing a equals 4 first? I'm pretty sure it's because when you the stack goes downwards, right? Memory goes downwards, so everything happens backwards. So if I had function input here, or function parameters in the void main function, and I had int a, int b, b would actually be first, and then it would be a. If I'm making a function call and I'm passing in two values, it's the second value first and then the first, right? So it's all backwards. And I don't know why I said I'm pretty sure. That's literally how it works. And then this accesses the second empty space in our stack, the value in the second empty space in our stack, and moves it into the EDX register, and that is 4. So it moves 4 into EDX. This accesses the value in the first empty space of our stack, which is not empty anymore, which is 18. So it moves 18 into EAX. And this adds EDX with EAX, and the result is stored into EAX, right? So it's always stored in the destination, at least in the Intel syntax. So EDX, if you remember, it has the value 4. EAX has the value 18. So 4, 18 gives 22. It moves EAX into ESI, so it moves 22 into ESI, which is used in the printf function to print whatever you want to print. This accesses the format string memory location and puts that into RAX. So I'm gonna go ahead and do NI a few times. You're gonna want to do start. You're gonna want to NI, and I'm gonna NI to 163. So I'm stopping at this instruction, and I'm gonna go ahead and print the value in the first empty space. So if I do this right, it should be the value 18, right? And as you see, we get 0x12. 0x12 in decimal is 18. So now I'm gonna go ahead and access the second empty space, right? And that should be 4. Yikes, what am I doing? Okay, just put a bracket instead of parentheses. So as you can see, that's 4, right? So everything that I explained in the last video, I hope is clicking. So now I'm gonna go down to one more register. So I'm gonna go past now I'm at 66. Okay, so I'm at 66 still. I cut the video for a second. So I'm gonna do info registers, and we're just gonna look in here, right? So if you remember, I moved 18 into EAX and moved 4 into EDX. So if we look at info registers, I click space again. No. Wait a minute. See all register data GDB. Info register. Okay, so just literally type it. Okay. Info registers EDX. Yeah, there you go. So EDX stores 4, EAX stores 18, right? So I'm going to do info registers EAX. That is weird. Very, very weird. Info registers. Wait a minute. Yeah, so I just needed to go one instruction ahead. Sorry, because 169 it hadn't executed this yet. So now EAX holds that. Okay. So now I'm gonna go one more out, and then I'm gonna do the same command again. Registers EAX. As you can see, it holds 22. Remember, I said the result of an addition operation, or subtraction, or multiplication, or division is stored in the destination. So it's stored into EAX, and as you can see, it holds 22. So I'm gonna do NI, and again, if we can just keep track, we can keep track of this. Now ESI holds it. And I'm not gonna check this one. You know what? I'll do it. I'll do it anyways. So I'm gonna do x/s. Oops, I want to put a $sign there, and then delete that. Okay, there you go. So as you can see, that's our offset. The memory address of where that string is located is moved into RAX because Lee moves memory addresses. RAX is moved into RDI, 0 into EAX because we have no return value, and then we just simply print F using our ESI and EDI. So you see how the addition operation is actually performed. So in your C code, remember I said that when you make a function call, it goes backwards, right? So this isn't performed first. Whatever is on the right is performed first. So if there was a third argument here, that would be performed first, and then the second, and then the first, right? That's how it works. So as you can see, B is actually stored first on the stack frame, and then A is stored when you make the printf function call. This addition operation is performed, and then this memory address is moved into EDI, and then the function call is made. So I hope this is a decent example of what's it called? Ignore these mistakes over here. So I hope this is a good example of two variables. This is a small one.